So today we will get started for the AP Comsci Principle course for the material that would actually help in your exam, okay? That's actually the exam will be in May, and then we need you to study the material that I will give you. Number one, there are a few things that I need to go over with you, making sure that you understand. Is that okay?
Yeah.
Okay, first thing is like, this one would have a new course shell. So you need to go to your Moodle class. Okay, Moodle class, there is a course called CS51, Computer Science Principle 2026. You need to get into here. Okay, that's the first thing you need to do. And actually, the picture I put in the group. So that's the one that you need to pick. Okay. Do you still know how to get to the Moodle website?
Yeah.
You need to go there, okay? And then all of the study material and exam set are there, okay? For exam preparation set are there. So when you go into here, you will see something like this. There's a textbook, but the textbook is too much. You can study it if you want to study it. You can download it, okay? It's a PDF you can download. So here it's too big, so you can download it, but you can download the textbook, and then there's a Coda.org course that I gave you before. You can also go to Coda.org for study, but Coda.org's study material is not very complete. Okay, and there is a KQED video crash course video for computer science. You can also study that, but it's not 100% aligned with AP Comsci principle. Okay, but anyway, there are also some video you can watch over there. So these are the study materials, but overall would be our own material that would be the best. Okay, so what you need to do to come to this website, and then every week we do have the lecture. So this lecture PDF, you can download a PDF for your study. Okay, so here, like this one, we have this chapter one's PDF. So this PDF you can download study. It's the same as the video, the PowerPoint we are going to use here. Okay, so it's the same. So that's the first thing that you need to do, that study material. Then after you study it, you also need to do quiz. Okay, this quiz is necessary. You must work on the quiz, and then work on the unit test as well. Okay. This unit test is actually coming from Barron's book. So if you download it, you will see that it actually comes with the photocopy from a Barron's book. Okay, but anyway, when you answer the question, can you do this? Can you actually create a text file? Let's assume that you actually try to answer a problem. So you create a text file. So this text file, let's assume is actually called AA. Okay, let's call it AA. And then let me open this text file. So when you type in the answer, please do this, okay? 5 problem a group. So let's assume that you have the answer of A, B, C, D, E. So you type A, B, C, D, E, and then the problem 6 to problem 10, you have A, B, B, A, B. Is that okay?
Yeah.
And then change that. So I will know when that's graded, I have a computer program will automatically grade it for you. So this one is question 1, 2, 3, 4, 5, and then have a space. And then 6, 7, 8, 9, 10. Okay. And then number 11 will be here. So you continue, and then until you finish it. If there is a pick two problem means that you have A, B, C, D, E, but you need to pick 2 of them. Then you answer like this. You answer AB bracket AB inside here. So I will know this one is a pick 2 problem. Is okay?
Yeah.
P2 problem means that you have A, B, C, D, E, and you need to pick two of them. So let's assume the answer is A, B, and you pick A, C, then you get no point. If two of them you need to be A, B, but you pick A, C, then you are wrong. They consider you are wrong. You have to write exactly A, B to get a 1 point. Is that okay?
Yeah.
Okay, make sure that you understand it, okay? So when there is a pick two problem, then you have to write something like this. So keep doing that. So you're doing that. So that's assume that you have many problems, something like that. And I have a computer program will automatic grade it for you, okay? But making sure that your number of the questions are the same as the question given here. So you can download the file from here, download this file to your local. These are copied from the parents' book, okay? So you can study that anyway. Okay, these are the regarding the homework. So today we will be working on the chapter 1, lecture 1. And then after today, you need to work on this unit 1 and return this. Okay, the quiz, you can answer it, but the quiz answer will be graded by the website. And this unit test, you need to do it. That's actually by parents. I will grade it for you. Okay. And then there are extra video that you can study as well. Those are optional, but sometimes it's good. Okay, there are extra video that say right here.
In order to understand what
you have extra video for
quality
software
assurance
development life
analysis does, you
cycle.
first need to understand the process.
Okay, so there are extra video you can watch as well. So these are very good material, and I will guarantee you my material is the best you can study. Okay, so I don't know how your teacher is going to prepare you for the AP exam, but so far I know there's no one's study material is better than us. Okay, is that okay? So you must work on the homework right here, and then at the end when we almost finish the every chapter, there will be a group of practice exam. These practice exam will be after the unit 5. There's an AP end of year exam review. At that time, we will need you to work on problem set according to the time. Okay, I haven't changed the time. This is still 2025. Okay, I need to change it to 26. Okay, I haven't changed the date yet, but I'll do that. Okay, is that okay?
Yeah.
But you need to do the study. Okay, but anyway, let's get started with chapter 1. Okay, so before we go to the chapter 1, let me talk about the AP ComSci principle exam. Let me check it. Okay, one moment. Okay. Let's look at the syllabus. Before we go to the chapter 1, let's go to the syllabus. Okay, syllabus is regarding this course. So this AP ComSci principle is a open material course. That means the teacher don't have any guideline of what should be taught or what should not be taught. Okay, that's the number one rule you need to know. So whatever covered by the teacher, everyone can be different, but they will have a end of year exam. So usually people use the end of year exam to decide what to teach and what not to teach. Okay. But in principle, this course is an open course, so there is no course standard. Okay, and here this is my name and my experience. Okay, so there are some curriculums. So this curriculum in the study material, this is from code.org website. So there are internet that you need to study. There are digital information you need to study. There's an algorithm and programming you need to study. There are big data, and then there are unit 5, building the app. Okay, so there are 5 units, and so far the AP exam also follow this 5 units. So if you go there, they are still using this 5 unit structure. So this 5 unit cover the big idea of the 7 big idea of the, let me see, of the AP computer science. Okay, so this 7 big idea is I may talk about it before, but this is 7 big idea is called kata peak, okay? You need to remember it now. This is kata peak is, let me show you how to memorize this 7 big idea of AP computer science. Let me change it to 48, on the 48. This is called kata peak. Okay, so 7 different letters. So first C is called creativity. Second, A is for the abstraction. Third one, D is for data. Next one, A is for algorithm. And then P is for programming. And I is for internet. Last one, G is global impacts. So these are the so-called 7 big idea, computer science big ideas, okay? So, and we remember it by using this, what I told you, using this idea of the way that I call it. It's called kata peak, okay? CADAPIG. Peak is a peak, okay? The animal peak. So it's a PIG is for programming, internet, and global impact. And then remember kata, okay? CADA, creativity, abstraction, data, and the algorithm. You need to remember that, okay? So let me give you this 7 big idea of the computer science. Okay, so basically this is 7 big idea being distributed to the 5 units in our AP concept principle curriculum. Okay, so they are unit 1. Unit 1 is called creative development. So today we will cover this unit 1, creative development. Then we will go to the unit 2, that's called data and information. So this one, the unit 1 cover the creativity, cover the first C. Okay, we have kata peak. So this one cover the C. Okay, and then data and information. This one cover the data. Okay, and this one programming and algorithm. This one cover the P and A and A. The other A is abstraction. Okay, one is abstraction, one is algorithm. So programming and algorithm abstraction. So this unit 3 covers 3 ideas. And then this one covers G. Okay, cover G is for global impacts. And then this one cover I for the internet. So far, okay. So this is CADAPIG. Okay, is that okay so far?
Yeah.
So these are the different units, how they distributed. So unit 1 will be on the creative development, talking about how you create programs. Unit 2 talk about data and information. So we'll talk about data and information. And then unit 3 talking about programming and algorithms, how to do programming. Unit 4 talking about hardware, so including computer and internet. Unit 5 talking about global impact, so data security, cyber security, and then other global impact issues such as intellectual property, such as digital divide, many impact that caused by computer. Okay, so these are the different ideas that covered by every computer science principle, and we will teach you unit by unit. And today we will be covering the unit 1, creative development. Okay. Okay, and then the textbook, we use this discovering computer. Okay, I show you already. You can download it from the internet. Okay, and then the textbook is really big, so I don't expect you to be able to read the whole book, but you can download the book for reference. Okay, and then here are core idea. Okay, we'll teach you later. So this one I think is okay. So K-12 computer science. course framework. Okay, and then this schedule are old. This one last year because this year we only have you as one student, so I do not revise it, but will be pretty much similar. Is that okay?
Yeah.
Even the week number can be different, but mostly will be follow this order. Okay, but it's okay. We'll get started with lecture one, creative development. Okay, let's get started for unit one then. So unit one, we go to this creative development. So this is the first big idea. So when we talk about computer science, you need to know about what is creativity. Okay, so creativity is very important. Okay, so AP concept principle exam starting from 2021 and 2020 to 2021 school year, the new curriculum being used. And last year, 2025, one more update being added to the AP concept principle curriculum. Okay, I'll talk about these 25 updates. So you need to study something in order to study it. And as I said, this AP concept principle is a open-ended course. That means no teacher knowing what need to be taught and what doesn't need to be taught. Everything can be taught, but under certain guideline. But usually you don't know what is within the boundary of what is not actually need to be taught. Okay, but anyway. When we go to the exam, there will be two parts. There will be two parts. So the multiple choice part will be 70%. So usually they give you 70 question, maybe 62 of the one choice problem and 8 of the pick two problem. Is that okay? But each problem will give you 1 point, and totally it make a 70% of your final score. And then you would have a project you need to work on, and then project worth of 30%. And in the past, you just submit the project and that's done, and then they will actually read the project for you. But now they change the format. So this is 30%. Will not be given by the readers for the project. So the project you still need to submit, but at the exam day, you will add 1 more hour to write down your answer. They don't want like your answer to be written before the exam because it happened that another student just be cheating. Some teacher write a report for them. You know what I'm saying? So they decided, no, that we don't want you to do it that way. So you will submit your project, and then in the exam, you need to, based on your project, to answer the question for 1 hour for the FRQ part. You know FRQ, right?
Yeah.
Okay, so that part used to be submitting the project, but now you still need to submit the project, but you actually will also need to go to the exam to write down your own answer, okay, to make sure you don't cheat. So this portion, we'll talk about it later, okay, but today's all of the 12 different chapters and 5 units, we are basically talking about this 70% multiple choice part. Is that okay?
Yeah.
Okay, anyway. So this unit 1 creativity will take up about 10% of the exam, okay? About 10% of the exam. So that's the unit 1. First one, we talk about innovation, okay? So this one is a little bit like when you go to SAT exam, it's a conceptual exam. Conceptual means that it's not operational. It's not by formula. So for example, if you go physics, if you have F equals MA and you calculate based on that, or you based on basically maybe your formula for energy, your energy is equals half of the NV squared. So you can calculate it, you can do operation on it, and this exact answer that you can expect. These are called operational problems. But AP ComSci principle is more conceptual problem. And you know what concept is conceptual? Conceptual is just like you do reading for the SAT. And based on your reading, you need to answer which answer is closer to the reading. So that's conceptual exam. It's okay? So sometimes the problem can be very, very vague or very blurred. You may end up answering the wrong answer because it's not like a math. You have clear cut of 1 or 2. You don't know. Sometimes it's very, very close. You have to compare. It's conceptual. It's okay?
Yeah.
So in a way, this AP ComSci principles multiple choice a little bit more like a data analysis course. So it's a little bit like a study for the ACT. ACT has a science section. So this one, the whole AP computer science principle is very close to ACT science section. Very close. I would say very, very close. If you prepare for this AP ComSci principle, you can also prepare it for the AP ACT science section. Okay. The two are very close. So first thing is that you need to know about what is innovation. So Liana, what is innovation?
Well, like,
Can you use a very simple word to talk about it? What is innovation?
creating or new ideas.
Yeah, just creating something new. Innovation is to create something new. So let's talk about, for example, like what is innovation? So doing a calculator, is that something new? Is that innovation? Use calculator, is that innovation? Use calculator, is that innovation? You use a calculator, is that innovation? 3 plus 5 equal 2. Using the calculator, is that innovation?
Well,
So these are conceptual problem, you know, I'm asking you, this is conceptual problem. So maybe in the AP exam, they will give you 4 examples, A, B, C, D, and which one is an example for innovation? Okay, and I ask you, is using calculator an innovation or not? Yes or no? You answer me quick. Don't think. Yes or no? Just answer me yes or no.
No.
No, why not?
Because like it's not creating a new idea.
So basically, okay, we talk about this is a conceptual exam. So conceptual exam, you means that you need to understand the concept and then answer the question based on the concept, right? So we say innovation is creating something new. And then we have an example of calculator. So is using calculator creating something new? Definitely not. Okay, but definitely not means that in the year of 2026, we don't see any innovation at all. But if we roll back the time to the year 1945, maybe using calculator is an innovation because at that time nobody has any calculator at all. You know what I'm saying? Is that okay?
Yeah.
So let's actually talk about something different. So, okay, recently the silver price go up, so people start to use a silver coin. So is using silver coin an innovation or not? Also not, because silver coin have been in human history for more than 400 years. Since the discovery of the Northern America, right? Spain come to the to Mexico to dig a lot of silver and create make a lot of silver coin and ship back to Spain. So is that an innovation? Definitely not, right? Is okay?
Yeah.
But how about Bitcoin?
Well,
Is it Bitcoin an
yes.
innovation?
Yes.
Yes, but the standard of 2026 is still an innovation because this Bitcoin is created as a digital currency, and then there's nobody used a digital currency before, and then they put into the blockchain, so you actually can use the blockchain to actually save protecting your property. So is that an innovation? Yes, that's an innovation. There's a new way to make payment. There's a new way to save your money. So that's the innovation. Is okay? So
Yeah.
here we study this AP computer science principle. I need to teach you a lot of notions, a lot of concepts, and you need to answer the question based on this different concept. It's okay?
Yeah.
So what I want to tell you is that this AP computer science principle is a little bit more like SAT, more like US history, less like computer science. Is that acceptable or not? It's more like a social study course than a science course. Is that okay?
Yeah.
Because right here we just talk about innovation. We haven't give you the need to write a program yet. Did we actually talk about any program to talk about innovation? No, we haven't, right? Whatever we talk about is still circulating around the idea of what is innovation, right? Is that okay?
Yeah.
So right here, you need to prepare yourself to make sure that you understand what is innovation. So innovation is very important. It's just something new. Okay. So in the past, my student, especially my son as well, when they go to the summer research program at the university, they do research. They work on the research. And then there's a question the people of the interviewer may ask them, what is research? What is research?
I just like collecting and analyzing data.
No, that's not. Analyzing data is not research. Analyzing data is a method used for research, but it's not research itself. Research is searching. Re is again, right? Re is again. This word root re means return again. Is that okay? So research means that you search and search and search and search. Search many, many times, again and again and again, to do searching. Searching for what? Searching for answer. Searching for solution. And also searching for something new technology. So research is a way to create innovation. Is okay? There are many ways to create innovation. Research is one of them. Research is one of them. Another way to do it is called experiment. Experiment is also a way to create innovation. So for example, like, okay, nobody created a light bulb before. So I decided that, okay, I would like to create a light bulb using silver wire or copper wire, and I would create a light bulb using the wire, using that. Is that okay? Okay or not, I don't know, but I would just do an experiment to burn it to make sure that I see the light. Can I see a light? No, I cannot because I fail, and the silver will be burned out, just like fuse. So you burn down. So the experiment failed, but that's one kind of research is doing the experiment. Is okay?
Yeah.
Another type of research is that you go to study some people's paper and then study book and doing something and you understand something and you work on the theoretical study. So you come up with a formula and you calculate and you do something for. So research had two parts. One part is theoretical study. The other one is experimental study. Either way is very important. Your theory need to be proven by experiment. Your experiment will build up your model, your research model. So research and experiment in combined, we call it scientific way of study. Does that make sense?
Yeah.
You hear of this before? Yes or no? You have to remember them, okay? And then you actually, the purpose of the research is to do innovation. So we talk about innovation, and then we talk about what's research, what's experiment, what is the method that we use for innovation, okay? And I talk about a lot. I haven't did this slides yet. So you need to do that as well. When you prepare for your own exam, you need to prepare that as well. You need to understand the concept and then being able to talk about it. Is okay?
Yeah.
Okay. Now, we talk about innovation. Now, next one is computing innovations. So computing innovation is using computer to do innovation. So there's a question, is computer innovation hardware or software? Is it hardware or software? Computing innovation, is it hardware or software? Actually, this question I'm asking is one of the questions that AP exam asked before. Is computer innovation hardware or software? So let's assume that the question I asked you is a hardware or software. So A is hardware, B is software, C is both, D is actually none of them, E actually I don't know which one.
Both.
Actually, the answer is that computer innovation can be physical or non-physical. So innovation can be an iPhone, that's a computer, and can be a software, you cannot touch it, it's non-physical. So it can be physical or non-physical, it actually come in of different shape or size. So it can be a hardware, can be software, can be a memory, can be a computer, can be a box, or can be a IC chip. Is that okay? Does that make sense? Okay,
Yeah.
now self-driving car maybe is a innovation right now, okay? And then smart appliance like refrigerators, watches controlled by cell phone, right now maybe is innovation. Tablet, okay, maybe is not innovation of today. But personal computer, it was an innovation in 1980, but nowadays personal computer considered not a new stuff. Okay, so these are something you need to remember. Software can be, depending on which software you talk about, a newer software maybe is a like AI, maybe is a innovation. But something like Word, if there's already a Word and you redo it again, design in different way, that will not be a innovation. Okay, if you follow people's existing software, then it will no longer be a innovation. Is okay? It must be something new, something that nobody think about it before. So in the past, when some student asked me to become a PhD research dissertation test, I always ask them, is your study new? Is your study complete or not? Have you complete everything or not? Third one, is your study true or false? Real one or fake? So we actually accept new PhD just these three things. Is your study new? Nobody did it before? Yes or no? Okay, if yes, you can graduate. Is your study complete or not complete? Complete means that you already think about everything possible. If you haven't finished your study, then you are not graduating for PhD. Third one, is your study true or not true? Are you making up or this new real thing or not? Okay, so these are the criteria we use to judge whether a PhD student should be allowed to graduate or not. Okay, that's the first idea we talk about is innovation. Second idea that we would like to talk about is collaboration. So, Liana, what's collaboration?
Like working together.
With who?
With like a group of people.
So if you are a programmer, is that true that you can only cooperate with some other programmer? Yes or no? We'll change another question. If you are a mathematician and you do cooperation, you do innovation work, can that person must be a mathematician as well or no?
They don't have to.
Have to or not?
No.
So who you can cooperate? Who you should cooperate with? Number one, who should you cooperate with? How can you know that who you want to cooperate with? How can you decide which person I want to cooperate and which person I don't want to cooperate with? How can you decide?
Like if you if you have the same goal.
What kind of same goal? What kind of same goal? What do you mean by same goal?
Like if you're working towards the same outcome.
Yeah. So before you do cooperation, you must have a team, right?
Yeah.
So before you build a team, you must have a project first. So what you talk about is that you must have a project goal. Let's assume that right now your project goal is to build a self-driving car. Okay, since we need to design a self-driving car, so I need to have some mechanical people who can build a car. I need to have a software engineer who can write the software to install to the controller and the pad for it, right? I need one person who is internal designer that can design the internal data sheet and then windswipers, whatever edge on the car to make sure it's pretty. It's interior designer. I may need to have a manager who control the budget for the project. I may need to have a finance person who talk to the bank to give me the funding. So every single one who actually try to achieve the goal of building the car are the people we actually want to find to help to build this self-driving car. And then we actually get some funding, say I get $2 million, and then I start to build my team. So how many people I needed, I don't know, but I need to actually come up with the idea of who I would need it. I need two mechanical technician. I need two programmer and one interior designer, one manager, and one finance people. Is that okay?
Yeah.
And then I'm the manager, so I put all of them together to cooperate to achieve the same project goal. So this is called the project goal. Okay. So basically, cooperation can be with the people that's of the different discipline, may not be of the same education background or different background. Okay, so actually it can be programmer, can be finance people, can be all kind of people you put into together to do cooperation. Okay. So sometimes you may need people, say you create a software, you may need people who actually have no software experience to test the program for you to make sure that your program can be used. So people from different background may give you different perspective. So discovery can be found due to the multiple perspective of the perspective. So many different people from different background may actually solve the problem. And more hands, more people may make the project working on faster. So more programmer will make it faster. Yes, these are same kind of people. Different kind of people can check the project with different way. So there are more people of the same discipline that can help the job to be faster. There are more people of different discipline. They will help you to debug the program or to look at the project in different perspectives. Is that okay?
Yeah.
Third one is that different people from different background may avoid bias. For example, if the whole team are only engineers, they will say, oh, let's do this. This is exciting, let's do this. But they may build a product that nobody would use, or they will build a product that actually wastes a lot of material because they never think about material cost. Then that would be a trouble. Is that okay? So for example, I want to build an iPhone. I must have an idea of, okay, the end of the product should be sold under $300. If my price is over $300, you give me a super powerful cell phone, but it's over $300, nobody is going to buy it. So before you actually come up with the final product spec, you need to know that what I should do and what I cannot do, what kind of feature I need to put in and what kind of neat feature I cannot put in. So those kind of things, if developed by some finance people or management people, would be better than the idea purely created by engineer, because engineer have no idea of the budgeting. Is that okay?
Yeah.
Okay. So these are different issues for cooperations. Okay, these are different issues for cooperations. So collaboration between user and peoples. Okay, so here we talk about is user people, and they may be at different phase. So initially you may need people to do budgeting, right? But at the end of the product, you may want people who come in to help you to do testing. So the people who come in to the project at different phases may be different people. Is that okay?
Yeah.
So right here, we do have a pair programming situation. That means that two people doing coding together. And there's only one computer. So one guy, this is a boy guy, we call it the driver. Just like you drive in a car. So he drive the car, he do coding. And the girl, okay, the one that actually this right-hand side is girl. The girl is called navigator. So this navigator means actually she's looking at the map and telling the boy to say, you drive this way, drive that way, go here, go there. But she actually don't have the control on the handler. She doesn't have the control on the car. She's a navigator. She only look at the map. Is that okay?
Yeah.
This model, we call it pair programming. When you have two people doing programming together, one guy typing the computer, that's called driver. The other guy actually providing the guideline or doing mathematical calculation. And this person is called navigator. Is that okay?
Yeah.
So whatever I told you today, you have to remember them, because when you go to the exam, they will test you these, okay? And I use these different slices because I give you the idea of what they are. And later, when you review the course, you can watch the video again. Is that okay? Hello, is that okay?
Yeah.
Making sure you understand it, okay? So this is called pair programming. You do have a check function of one driver and one navigator. Besides that, you also would have a tool like GitHub or Bitbucket. So everybody have the same website. You submit your program to the same website. That's called your cooperation tool. So cooperation including people who do what, also including tool, what is the common language you want to use. So you may hire 3 people in your programming team, but let's do this. That's everybody speak English. Don't speak Chinese. Is that okay? Is that okay?
Yeah.
That means you need to have a common language. I just use Chinese and English as an example, but that common language means that you have to have a way to communicate. Maybe it's a tool, maybe it's a language, but you need to come down with only one language. You cannot say, oh, I want to write my document in Chinese because I don't know English. And the other guy say, oh, I just want to write the document in Japanese. I don't like the English. It doesn't work if you have international people. You cannot have those people to work that way. You have to tell them, no way, don't do this. That's just put all the document in English. Is that okay? Otherwise, nobody can understand. Okay? So that's on communication is also the key for the project. Does that make sense?
Yeah.
Okay, so you need to be a cooperative person. You need to help out different space of the project. Be a good team player. So if I ask you a question, if I'm the interviewer for a summer research project, okay, and I ask you a question, Ariana, do you like to become a working in a team or you like to work individually? Which way? Do you like to work in a team that people work on 30% here, 20% here, or you would like to become a individual worker? I work on my own module. You don't bother me, I don't bother you. Which way?
Like
You prefer
individual.
individual? No,
Yeah.
no. This question, if the interviewer asks you this question, your answer should be, I will be open for either way. If you need me to work on the individual project, I can work on it by myself. I'll take care of my own portion. If you need me to work in a team, and I will be able to, I will actually be a team player and help out my own teammates and also doing my own parts and cooperate with my teammate. So I asking you this question, the answer is not either way. You cannot answer, I just want to work individually, or I just want to be a team member. So if you say I'm just want to work on as a team, I don't like to become an individual worker. Then the question comes, if there's no team member, then what should you do? You are dead, right? You got kicked out. If you don't want to, you cannot work. You cannot work by yourself. Every time you need to depend on other people. Then that's not good, right? And either way, you say, "Oh, I just want to become an individual contributor. I don't want to team up with other people, or I don't prefer to do that." That's also not the answer. Is that okay?
Yeah.
Okay. Anyway, be a good team member is also important. Communication is very important. When you do communication, there's some protocol you need to follow. A common language, common tool need to be used, okay? So program, you actually have different functions. So your program may be divided into input and output. So you have input and output, and you have code segment there. So before you actually do that, you need to, before you write your program, you need to come up with a specification, okay? So specification is what you need to be done, you need to done, okay? Let's go to the software lifecycle part. So basically, okay, let's assume that you actually would like to develop a software. Let's assume that right now you are writing a program for a hospital. Step number one is understanding the requirement. So there will be a software, so there is a front desk. So there's a person, there's a nurse helping out to check in. Okay, so check in, Liana Fang, number 25. Okay, she's waiting. So she go to the clinic and wait outside until she's called to go into the clinic. When she go into the clinic, then there is another doctor sitting there. So let's assume we have a doctor sitting there. And then the doctor look at you and then writing down prescription and your symptom and everything. So there's a computer and then putting down patient 25, the end. Today she's coughing. Okay. So this system that actually describing how to check in, how to register the person, how to actually write down his medical requirement. These are the system used by the hospital. So you talk about how many computer needed or how many software needed. That's called requirement analysis. That's the stage number 1. So you decided that there's one computer needed for the doctor, one computer for the front desk, and one computer for the pharmacy. And then they should share a database together. So that's the piece of software we are going to develop. That's called requirement. Is that okay?
Yeah.
So after requirement analysis, you come up with a specification. So this spec actually is a contract between the user. So the user is the patient, and then between the user is the patient and also the doctor and the technicians. Okay, between the user and the designer, the manager of the project, who design the software for you. So you need to tell them what you need to do, what software you need to design. So that's requirement analysis. After you finish that, okay, then we break down that software to several pieces. Each piece is written down by one engineer. That part is design. Okay, and then writing the code is implementation. After you finish the code, you do testing. That's called verification. Finally, you upload your code to the website and maintain the website. That's called maintenance. These are 5 major steps in software engineering. Is okay?
Yeah.
This whole thing, we call it software development life cycle. Okay, and right here is also waterfall model. So this waterfall model later developed into V model. V model means waterfall here, getting smaller and smaller, and then getting bigger and bigger. This actually, when you do testing, you get it bigger and bigger. It's called V model. So you either follow the V model or waterfall model, okay, to develop software. And there is another one called spiral model. Spiral model is that you started from a small project and gradually make it bigger, 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 bigger. Okay? That's called spiral model. So there are 2 types of the development. One is called iterative development process. Iterative development means that you have several stages. So you do several iterations. So go through every stage 1, 2, 3, 4 different times. It's called iterative development. Okay, go through the design cycle several times. And there's another type called incremental development. So let's do one small piece of software first time. Second time, let's add 2 more functions to it. Third time, that add another 2 more functions to it. So gradually you build up your system step by step from small to big. It's called incremental. Is that okay so far?
Yeah.
Either way can solve the problem, okay? So after your first stage, you finish the specification analysis. You would write down your document. We call it specification. Okay. And there are sometimes comments. Comments actually are useful because you need to have people later will look at the comment to understand what project is going on. Okay, what is going on the project. That's called comment. Next one, you need to be able to identify your error in your project. There are 3 types of error: logic error, syntax error, and runtime error. And there's a 4th type error called overflow error, okay? But usually this one doesn't actually keep there. So first type is syntax error. Syntax error means you write Python and you do not follow the syntax. So if, for example, you say if A equals 3 and parentheses and curly brace, sorry, you are wrong because this is a JavaScript format. It's not Python. Python is using if A equals 3 colon. They don't use a curly brace. So that would call it a syntax error. Is that okay?
Yeah.
So syntax error means that you doesn't follow the language and the compiler doesn't allow you to pass. Then it's called syntax error. So first, if you compilation fail, it's called syntax error. So sometimes you may pass it, and when you run the program, you may end up with problem that's called runtime error. So runtime error usually is like 3 divided by 0, that's a runtime error. And you have an array of 3 elements, 0, 1, 2, but you try to access A10. There's no data at A10. That's index out of bound problem that will cause the runtime error. Is that okay?
Yeah.
So syntax error is compile time error. You can see the error when actually you write a program and the compiler will detect it. And then if the compiler doesn't detect it in the runtime, your program break. It's called runtime error. Okay. Sometimes there's no error on compiler. You run it also pass, but the program result is not what you wanted. That's called logic error. For example, you actually say, what is your age? But your age is -10. It doesn't make sense because nobody has an age of -10. Then we call it a logic error. It's okay. It doesn't make sense. The mistake happened. You calculate the program and then it give you the data that you don't want it. Unexpected data. Is okay? But compiler okay. Compiler okay because compiler say age equals -10 is okay. Runtime also okay. Nobody complained that age can be assigned by 10 -10. But in reality, there's nobody has the age -10, so it's called logic error. That doesn't make sense. Is that okay?
Yeah.
So these are 3 types of error. One detected by compiler, one detected when you runtime you break. The third type is actually it doesn't break, but it actually create logical error. There's a 4 different type of error that called overflow error. For example, that you have A equal 0.1. So A plus A plus A plus A plus A equals 0.4. And this one you may return false. But theoretically, 0.1 plus 0.1 plus 0.1 plus 0.1 should be 0.4. But when you check it, it may not be true because you have overflow error. Because when you do calculation, they may be 0.99999. There's 1 bit error, 1 small bit error being created by the register. Is that okay so far? Is that okay so far?
Yeah.
So remember these 4 different type of errors, okay? And then you need to fix the problem, okay? Okay, now let's look at one problem. Let's do fix bugs, okay? Let's look at this one. So this one is a problem in AP concept principle. You look at it, tell me A, B, C, D, which one is the answer. So var appear in the list of my list. The procedure doesn't work as intended. There's something wrong, okay? So what is the something wrong? So first one, you need to understand what's the purpose. The purpose is to calculate to count the number of occurrence. So you see how many times the ball show up in my list. So my list is array. So that's when you have 1, 2, 1, 3, and then your value is 1. So it happened 2 times. Is that okay?
Yeah.
Now, will this one calculate the number of occurrence for the value ball? Will it or will not? What's wrong? Take your time, okay? Do you see what's wrong?
Well, line 5 is in the for each item loop.
So what happened?
Like every time the loop runs, like the count will like go back to 0.
It reset. So what should you do?
Like move it to
Move it to
move
here.
it to yeah, after line 2.
So which is the answer?
C.
C. Okay. So you correctly pick it, but remember, you have 2 hours, 120 minutes. You need to solve 70 questions. So each question is less than 2 minutes. So if you think about it so long, you probably may answer it correctly, but you will run out your time. Does that make sense?
Yeah.
So you need to prepare yourself, train yourself, making sure you can answer the question quick, okay? Does that make sense?
Yeah.
Okay, so you need to know what's algorithm, what's a programming language, what's ambiguity. Okay, I think it's okay. And then why you need to have a programming language, okay? Okay, anyway, this portion, I think this chapter, there are several types of programming language. I think this is okay. We don't test on these in the AP exam. Okay, these are extra materials. I don't think AP will do it. Let's look at the first video. What you should learn for programming, okay?
My grandson, Micah.
Can you hear it?
literally 3 hours.
Yeah.
And that day we played 30 minutes and he came back and said, "Can we go on?"
Let me make it louder, okay? One moment. Let me stop it right here. Let me make it louder. Let me make it louder before I play it back again. Okay, right here. Well, this video is a little bit on and off.
Here, Reddit user CS-NL posted this question to the internet. Reddit, my friends call me a scumbag. because I automate my work when I was hired to do it manually. Am I? CSNL was hired to do manual data verification and fixing on this gigantic Excel table, rows and rows of it. He was hired in this department of a bunch of people whose job it was for 8 hours a day, 5 days a week, to just do this to a giant Excel table. And they were pretty good at it. The typical daily output was 6 to 10 records a day with about 90% accuracy. Now, CSNL knew some basic programming, so he worked
Okay, this one I think
with
is
the script.
taking too long. Okay, let me summarize. What he want to say is that there's a lot of data entry job. Those will take a lot of time. So you write program to help you, it will save your time. And nowadays, even so, because you can use AI to help you to process the data. Is that okay? So AI and program can boost productivity. That's what he want to say. So this one I think is too long, and then this video is on and off, so probably not good to read, okay? But I'll keep you to watch by yourself, okay? Let me share this one. You actually look at it after class. Right now, I feel like this one so far, it has been on and off. Okay. Anyway, what I want to do right now is that we finish the unit 1, okay? So I will work with you on the unit 1 exam problems. Is that okay? This one, I will do it with you. So next chapter, before you go to the class, you work on the chapter 2 problem. Is that okay?
Yeah.
So let's download this one. Let me actually download it, okay? Okay, let's work together, okay? Because we are reviewing courses, so not only the concept, I also want you to be able to solve the problem, okay? So now the question 1, which of the following not true about computing innovation? You see, now it's question about computing innovation. So which one?
B.
Which one?
D.
Yeah, B is a purely hardware is wrong. Okay, we talk about it's not purely hardware. It can be hardware or software, okay, or can be any format, and maybe only a concept, okay? So you see, the conceptual problem is like this, okay? Number 2, what can the inspiration for computer innovation come from? Who can inspire you to do innovation?
And A.
Can be from anywhere, yeah, yes, A, okay, problem 2 is A. Problem 3, who can create computing innovation? Industry, people, companies, or other innovations? Who or what create innovation?
Mm, B.
People, okay? Number 4, which of the following trait is not necessary for cooperation? What is not important for cooperation?
C.
What does C really mean?
Like how close you are.
Yeah. How close you are not important. You actually can be remote doing something. Okay?
Yeah.
You need to have a communication. You need to have the common sense. You need to avoid conflict. Okay? Number 5, what is a program?
Mm,
A collection of program statements that perform a specific task. Or second, a collection of program statements that are part of an algorithm. So how software behave and how it functions. D, a code segment. Which one?
A.
Why? Everything are very similar. Why? Why A?
Because it needs like, well, the computer needs like,
It has a complete task. Okay? It has a complete task. Other thing may be part of it, maybe code segment. It is not a whole program. So this program means that the program for hospital, it had to be including the hardware, software, everything. Is okay?
yeah.
You cannot be just a part of algorithm. Part of algorithm doesn't mean it. Okay. So number 6, what is the code segment?
B.
Number 6, B, yeah. Number 7, what is true about program inputs? Okay, now A, do they have to be the same type or no?
Warning, empty page. Warning, empty page.
I'm sorry, I hit
Warning,
something wrong.
empty page. Warning, empty page.
How comes this Adobe keep doing the same thing? Won't you stop? Okay, sorry. So do they have to the same type? The input for the function have to be the same type?
No.
Of course not. You can have integer, you can have float, you can have string, so it's not, okay? B, a single program take in a single input and single output. Is that true?
No.
That's also false. C, a program input need to be text-based. It must be no, right?
No.
It can be audio, can be video, can be anything. Okay, so it's the answer is D. Okay, come from everything. Number 8, what is not true about an event? Which one is not true about an event? So what is an event then? Before we answer this question, what is an event? I teach you before, what's an event? When you do JavaScript coding, you have onClick, you have onChange. Those are events. So when you have a mouse click, that's an event. So what is the event? Which one is not true about the events?
B.
it will affect some consequences, right? So B is wrong, okay? C is correct, its trigger can be triggered by a mouse click. D it can affect the flow of execution and event associated with an action and the input, okay? It's okay?
Yeah.
Number nine, what is number 9? The designer program incorporate investigation to determine requirements. So you talk to people, and most programs are designed to use by people other than programmers to meet the need of the users. So you need to talk to the hospital people, and then investigation identify program constraints, the concern of interest, which of why is not true about the investigation.
A.
Why A?
Because
How elegant it is not determined by the spec, right? It's by the engineer. Okay.
yeah.
Number 10, what type of error this one is? It has some error. So do you know what's the error it caused here?
Mm,
So number one, you need to remember that when you do the AP concept principle exam, the kind of code that they give you is pseudocode. So pseudocode is not real language. It's not real, it's not Python, it's not JavaScript, okay? And here you have this sub-zero. So pseudocode, the index starting from 1 doesn't start from 0. So this 0 has index out of bound problem. So index out of bound problem will cause what? What type of error?
runtime.
Runtime error, okay? This one will cause the C runtime error. So far, does this help you to study the chapter?
Yeah.
So we will do this, okay? We'll do this for the whole semester, making sure each chapter you know it, and we will review the chapter test. So next chapter, when we go to the chapter 2 before the class, you need to work on the chapter test. So when we review, you already studied the problems, okay? You may be wrong, maybe right, it's okay. You submit the answer. So this is chapter 1. After the class, you can redo it by yourself, okay? But putting back a text file with A, B, C, D, those kind of things for me, I will grade it for you, okay? Does that make sense?
Yeah.
Number 11, the following procedure intended to add two variables A and B. So you have A and B, and then you display A plus B. What type of error will this procedure cause? Number 11, what will be wrong? So it can be logic error, can be syntax error, can be runtime error or no error. So added two variable A and B, what type of error for the following procedure will cause?
B.
Why B?
Because like it it won't recognize the command because it's like there's a spelling error.
Yeah, it's a spelling error. It's a DISPLAY, okay? So spelling error. So this one will cause the syntax error, okay? This is a little bit tricky. Number 12, what type of error the following procedure cause? There's an error. So this is intended to disperse 4 added to the value contained by the variable A. So number 12, no error, okay? This one is no spelling error, so this is no error, okay? Number 13, you will display 4 cat 4, is that true or no? There's no error, okay? This one also no error. Okay? Number 14. What type of error of the following procedure will cause? Number 14, what type of error it will cause?
Runtime.
No. The error is this A has no definition. You're missing a parameter A here. So you miss a parameter A there, what will happen? It is a syntax error, okay? Variable undefined. Syntax error, is that okay?
Yeah.
Okay, you need to work on faster, okay? Number 15, the display A, this one, it has it. So what's wrong with this one? Number 15, what's wrong with it? Or no error, which one? So line 1 error, or line 3 error, or runtime error on line 3, or no error, which one? Did you see something wrong or no?
Syntax.
Which part?
Well, there's no parentheses.
Yeah, there's no parentheses, so it's a syntax error, okay? But you do need to come out faster because so far, if you answer this way, you will run out of time, okay? One problem need to be done within 2 minutes, shorter than 2 minutes, okay? Number 16, which is the number cause overflow using 1-bit storage? Will not cause an overflow.
B.
Okay, 1 bit can only be 0 or 1. Over than that, it will overflow, okay? Number 17, which large number will not cause the overflow by 3 bits? 3 bit large number is 3 bit. What is the large number? Largest number?
Um.
111 is what?
C.
7, okay? So it's 111, you say 1, 2, and 4, plus together, this one is 7, okay? Is okay?
Yeah.
18, how many bit can 1 bit storage hold? How many number? You have only 1 bit. So 1 bit, you can hold 0 or 1. How many number?
2.
2 number, okay? So 4 bit, how many number you can hold? You have 1, 2, 3, 4, 0 or 1, 0 or 1, 0 or 1, 0 or 1. How many numbers?
16.
16 numbers, okay? 19 is 16 numbers. 20, which of the following code error will the following procedure cause? So the number mark 2 equals 1 is called even. No, actually it's wrong. If mark 2 equals 1, that's actually odd, but it says even. So even you say R is say even. So what's wrong?
A.
Number 1, the syntax is correct. So there's no syntax, a wrong answer, no error. So it's error on here. So you need to change the mark 2 equals 0. Okay, so it's a logic error on A. Is that okay so far?
Yeah.
Number 21. A programmer is working on the algorithm to sort the student by their grade average GPA. The program wrong but not correctly sorting the student. So you try to use a sorting algorithm to sort the GPA, but the program doesn't sort it. The programmer try to debug the program but cannot figure out where the error occurs. So which one may be able to fix the problem? Okay. You try to sort the data, but it doesn't sort. So what may be going on wrong and how can fix the problem? So number A, post the program to social media. B, redesign the program so sorting no longer a function. C, ask a peer with a fresh eye to look at the code. D, take the code from the internet and that sort the number, so actually copy from other people. So which one is the answer? Should you post the program to the internet to help you to do debugging?
No.
No. Should you redesign the program so the sorting no longer a function, you put it as a loop instead of function? Would that be working?
No.
No. How about she asks a different person to look at it?
Yeah.
So this one is a cooperation problem, okay? Collaboration problem. You use a fresh eye to solve it, okay? Number 22, which of the following is not calculated of the cooperation? Which one is not cooperation? We already answered the question before. It's a proximity, right?
Oh, A.
A, okay. Number 23, a programming team is developing a program computer game where a throw is an adventure where throwing bugs and boogers at the block to gain point while making blowing noises. Although the game runs smoothly without any error, both adults and children say that they don't like the game. So then you write a program and nobody like it. So which of the following step in the design should the program revisit first? You have a program and then the user don't like it, and then what should you do? Test the program, prototyping or designing or investigating and refactoring. Go to which step?
A.
A is go back to stage 1 requirement. You may not meet the requirement for the user because you design some program that nobody wants. So you test the code, it doesn't help. It's not a programming bug. You do prototyping, that's not something wrong. You already did a prototype. You actually redo the prototype, doesn't help. An ugly program is still an ugly program. Redesign the program that may help because you already built a wrong model. Okay, so A, reinvestigating and reflecting. Okay, is that okay?
Yeah.
So this unit 1 is shorter, so we go through it to give you the idea of what is AP Computer Science Principle Exam is, and what are the concepts and the way that you need to answer the question. So today we are up to here, and next week we'll go to the chapter 2. So what you need to do right now is that you should revisit this problem set by yourself. Give me the ABCD in text, okay? And then after that, if you have time, work on the chapter 2 project unit test, okay? Is that okay here?
Yeah.
And there are also extra quizzes you can work on, okay? That will help you to study, but if you don't have time, it's okay. But this one you must have, okay? Okay, any questions so far?
No.
Besides that, if you still have question about your school homework or exam, you still need to let me know, okay? Because I don't know what your teacher will test, okay?
Okay.
If no question, that's it for the day, okay? Good night and bye-bye.